All right, section 1.6 is talking about inverses. What does inverse mean? Opposite. What's the inverse of addition? Inverse of multiplication. Division, right? What's the opposite or inverse of taking the square root? Squaring a number. Okay, good. So we're going to talk about inverses in a couple different ways. We're going to focus today on algebraically. We're going to focus today on algebraically. We're not going to do much graphically until later on in the year, but algebraically is what we're going to focus on. If you guys notice here, here's two functions. We're going to talk about these two functions and compare them. First thing I noticed is one of them says f of x, and one of them has a little -1 on it. Right? Your original function is the f of x. The one with the little -1, that's our inverse notation. So when you guys write your answer, when I say find the inverses algebraically, your answer should start off with f -1 of x. Everybody see that? Now look at the two functions themselves. X plus 4 in the green and x minus 4 in the yellow. What do you notice is different? Okay, one's addition and then the other one's subtraction, right? And now exactly, look at the ordered pairs. In the green function, I have 1, 5, 2, 6, 3, 7, 4, 8. And the yellow function, I have 5, 1, 6, 2, 7, 3, 8, 4. What happened to the x and y's in the inverse? They switched, okay? So algebraically, we're going to switch x and y and solve. Graphically, your coordinate, your ordered pair switches. A lot of people think if you have a function, like just say we have, here's my ordered pair, and I have a function that looks like this. All right? If it was an inverse, it would flip over. That's not the inverse. That would be a reflection. An inverse is going to flip over the line y equals x, that diagonal line that goes through the origin. So if you were to graph this and then graph its inverse, it would be a reflection over that xy, the line y equals x. So whenever you're asked to graph, if they give you like a set of ordered pairs, they say graph the inverse, how would you do that? If I gave you these ordered pairs and I said graph the inverse, what would you do? You'd flip them and then just plot the points. That's it. That's what that looks like graphically. All right, so let's talk about algebra for a second. All right, if we talk about algebra for a second, we're going to do a question here, an example, where you're verifying that something is an inverse. We're going to do an example here where we're verifying. We're figuring out which one is the inverse. And then we're going to actually find algebraically the inverses. So this goes along with what we talked about with our composition of functions in 1.5. Okay? If you have two functions and you find the composition of one and then the composition of the other, you can verify that they're inverses of each other. What did I write right there? What does that say? Would you read that? Okay, f of g of x and then g of f of x. So what is this first problem or example telling me to do? Take the g and do what? Plug it into f. I'm going to take the g function and plug it into the f. And we're going to simplify from the inside out. So I have my f function is 2. Instead of x, I'm going to write the cube root of x plus 1 divided by 2 cubed minus 1, right? Now, we're not solving anything. We're just simplifying from the inside out. So when I see here is cubing a cube root, what happens to that? It cancels. So now I have 2 times x plus 1 over 2 minus 1. Now what? What cancels out? We're simplifying. The 2's cancel. So then I have x plus 1 minus 1. What happens? The 1's cancel, and I'm left with just an x. Everybody with me? Mm-hmm.
Can't you also do it? Because I know, like...
Algebraically? Yeah. We'll talk about that in a second. Now, this, we're going to do the exact same thing, but opposite. We're going to take f and plug it into g. So I'm going to take the f and plug it in to the g. Everybody with me? So I have the cube root of, instead of x, I'm going to write 2x cubed minus 1, and then finish the function, plus 1 divided by 2. So simplify, ladies and gents, from the inside out. What can I simplify? The negative 1 plus 1. Perfect. So I simplify from the inside out. Keep telling yourself that. Then the 2's. Then I have the cube root of x cubed, and I get, what'd you guys notice? They're the same. When you plug one function into the other, and then vice versa, and you get the same answer, you verified that they're inverses of each other. At the beginning of this problem, it says show that the functions are inverses. They're already telling you they are. But you can kind of visually see. And there's a good way to check, and you just brought up a good point. Sophie brought up a good point about algebraically being able to check, and I'll show you guys that in a second. But if you look at two inverses, sometimes you can tell that they're inverses of each other or not. Sometimes you can't. But if you compare f to g, in the f function you were multiplying by 2, and the g function you were doing what? Dividing by 2. In the f function you were cubing it, in the g function you were cube rooting it. In the f function you subtracted 1, in the g function you added 1. You guys see that? Sometimes that's a good way to just kind of check. Like when you physically, algebraically find the inverse, you can kind of check the original versus your inverse and kind of be like, oh, okay, yeah, everything was the opposite. Yeah.
Could there be a situation where the x could also be cubed? Like for the left, if the x is also cubed inside of the square root?
Yeah, it just depends on how the problem's written. Yeah. All right, let's look at this one. This is a different kind of question. It says, which functions are the inverse? Now, in a second, I'm going to remind you. I'm not going to show you because everybody's already seen this before, but I'm going to remind you how to find the inverse algebraically. But we're going to use compositions right now just to pick which one. Now, these kind of look similar, but do they look exactly the same or exactly opposite? No. Could you probably figure out which one is the inverse just by looking at it? Yeah, because all they did from here to here is what? They flipped it. But if you notice, well, let me just do the composition first. Let's do the composition of f of g of x and see what happens. All right, so I'm taking g and plugging it in to f, right? So 5 over x minus 2 over 5 minus 2. Is there any way I can start to simplify from the inside out? Anybody? Do you see anything that I could do? The 2's? Well, a negative 2 and a negative 2 is going to be negative 4, right? They're not going to cancel. If it was a plus, maybe. The problem with that is, I understand, because you would keep, change, flip, right? But then you still have those two negative 2's. They don't cancel out. So you wouldn't, the x would be like x minus 4. Let's try to take the h function. Well, no, let's do f of h of x. Let's try that one. Take the h and plug it into f. So I have 5 over x plus 2 minus 2. If I simplify from the inside out, what happens with the 2's? They cancel, so then I'm left with 5 divided by 5 over x. Do you guys remember? Keep, change, flip. God bless you. Keep the 5, change division to multiplication, and flip. What happens? They cancel out and becomes what? X. All right, now if we did it the other way, if we said h of f of x, that means we take f and plug it into h, right? So we'll simplify from the inside out. So I have 5 over over x minus 2, right? And then plus 2. Does that look very similar to what we just did? Now, some of you are like, God, this is so confusing. And that's okay. You don't have to find inverses like this. This would cancel, and then we'd have the same thing up here. We'd keep, change, flip. We cancel, we got x's. We're good. But algebraically, you can find the inverse here. Does anybody remember how to do this algebraically?
You set x to y and y to x.
Yep. What happens with the ordered pairs? My x and y in my original function, what happens when I graph the inverse? What happens? The x and y do what? They switch. All right, so algebraically, guys, we're going to do the same thing. All right, graphically, I just talked to you about this. This is the line that your inverses reflect over. That diagonal line that goes through the origin, positively. X becomes y, y becomes x. So algebraically, when you're figuring this out, in the equation, first of all, you'd find out if there is an inverse, but we'll talk about that on Tuesday. But you're going to replace f of x with y and then switch or interchange x and y and solve. All right, watch. First thing I want you to do is replace f of x with what number? What letter? Y. So y equals 5 minus 3x over 2. If I'm finding the inverse, what happens with x and y? They switch. So do that. X equals 5 minus 3y divided by 2. We are now solving for y. So go back to algebra 1. How would you get y all by itself? Multiply both sides by 2. Perfect. So I have 2x equals 5 minus 3y. I'm still solving for y. I'm going to subtract 5. Good. Subtract 5. So 2x minus 5 equals negative 3y. Still solving for y. So now I'm going to, whoops, I should probably not write with a highlight. Divide by negative 3. And I get y equals 2x minus 5 over negative 3. It's fine to leave it like that. If you guys would like to rewrite it as negative 2x over 3 plus 5/3, that's fine as well. Either one. But what notation should go in the front of my inverse? F negative 1 of x. If it's a g, g negative 1. Again, either one of those is fine, the top or the bottom. But here's a way that you can kind of give yourself a little check. Look at your inverse compared to the original. In the original, we had a positive 5, correct? In my inverse, I have a negative 5. In your original, you were multiplying by negative 3. In the inverse, we're dividing by negative 3. In your original, you were dividing by 2. In your inverse, you're doing what? Multiplying by 2. You should be able to go from your original to your inverse and kind of just give yourself a little check. Hey, is the opposite there? The opposite there? The opposite there? We're good. Does that make sense? So if I look at number 2, what I want you to do, first thing is cross out f of x and put y. So y equals 3x plus 4, divided by 5. All right, before I start solving, I'm not solving for x. What am I solving for? Y. I have to switch the places of x and y and then solve for y. So what am I going to do first, my friends? I'm going to multiply both sides by 5. Good. So 5x equals 3y plus 4. Still solving for y. I'm going to subtract 4 from both sides. So 5x minus 4 equals 3y. And lastly, I'm going to divide by 3. So y equals 5x minus 4 over 3. You're welcome to leave it like that. If you don't want to leave it like that, then you can separate it. 5x over 3 minus 4 over 3. That's fine as well. But what notation needs to go in the front of your answer? F negative 1. Either way that you leave your answer, you need to have f negative 1 of x. Because that says, hey, here's the inverse. And if we take a second to check, in the original, I was multiplying by 3. In the inverse, I'm dividing by 3. In the original, I was adding 4. In the inverse, I subtracted 4. And in the original, I divided by 5. In the inverse, I multiplied by 5. Everybody with me? Okay. Last one. Last one. I need to algebraically find the inverse. So that means I cross off g of x and I put a y. So the square roots of 2x minus 3. Switch x and y. So x equals square root of 2y minus 3. Now it's the opposite of square root. So if I square this side, then I have to square this side. So I have x squared equals, when you square a square root, it cancels out. So you have 2y minus 3. Now what? Add 3. So x squared plus 3 equals 2y. And now what? Divide by 2. So y equals x squared plus 3 divided by 2. Or, you guys want x squared over 2 plus 3 over 2. That's fine as well. But what notation needs to go there? G negative 1 of x. Whatever letter you start off with is what you need. You do not have to separate it if you don't want to. But again, go back and check. Okay, in my original, I had the square root. And in my inverse, I was squaring. In the original, I had a minus 3. In the inverse, I have plus 3. And in the original, I had 2 times 2. In the inverse, I have divide by 2. Question?
For the other answer, you can just put y, you don't have to put g.
No, you have to have, always have to have the inverse notation. I'm just saying you can separate it or not. But yeah, always have to have that inverse notation. Questions? Okay.